So, alright, we have f has a continuous second derivative for all x. F of 0 equals 2, f prime of 0 equals negative 3, and f double prime of 0 equals 0. Let g be a function whose derivative is given by g prime of all this stuff for x. Okay? So, you got to be really careful on problems like this where they give you an f and a g and make sure you're answering the question about the correct part that they're giving you. So, write an equation of the line tangent to the graph of f at the point where x equals 0. So, we're using f. We need a point on the line. Daniel, quiet. So that would be my f of 0, which is given to me. It equals 2. So 0, 2 is your point on the line. What else do I need for a tangent line? Slope. How do I find slope?
It's f first derivative of 0 equals
F prime of 0. And that's also given to you, which equals negative 3. So here's your slope. So now you just have to write an equation for it. So y equals negative 3 times x minus 0 plus 2. Of course, that minus 0 there is not necessary, but you can put it if you want. Don't if you want. It doesn't matter.
If it's not necessary, we can just put negative 3x plus 2.
Yeah. Yeah. They're not going to count off if you write it like this. They're also not going to count off if you don't put the 0. Either one's fine. All right. Okay, so is there sufficient information to determine whether or not the graph of f has a point of inflection when x equals 0?
Yeah,
Explain your answer. Okay, so let's think. Point of inflection. That's talking about concavity, right? Changes in concavity. So, for points of inflection, what do we have to look at? Second derivative. Please pay attention. Alright, so second derivative has to change signs.
There's not enough information.
We do know that f prime of double prime 0 equals 0, but we don't know if it changes signs. So, it is possible that you have a point of inflection here. Because if it's a point of inflection, you have to have a second derivative equal to 0. But we don't know for sure that it's a point of inflection. So, you could say, you could word it exactly like I did on the key, or you could say, it is possible that f of x has a more point of inflection. Probably don't do that on the actual thing. Has a point of inflection at x equals 0 because f double prime of 0 equals 0, but we do not know if f double prime of x changes sign at x equals 0, so there is not sufficient information to determine whether or not f has a point of inflection at x equals 0. So some form of this, I've worded it differently on the key, but same idea. We have to know whether or not the second derivative changes signs to know whether or not we have point inflection. Yes. We probably are not going to get through a lot of it. It's something I've kind of done before. Okay. All right. Everybody okay on A and B? Okay. Given that g of 0 equals 4, write an equation of the line tangent to the graph of g at the point where x equals 0. So same as A, but now we're talking about g. And so g of 0 is given. G double prime, they give you the equation for it. So if we're finding G double prime of 0, I'm sorry, not double prime. I'm putting double there. Just G prime of 0, then we're just plugging into that equation that they gave us. So it's e to the negative 2 times 0, 3f of 0 plus 2 f prime of 0 here. Write that down so that they know that that is what you're doing. I know, and then start plugging in numbers after that. So you're going to get e to the 0, 3 times f of 0 is 2, f prime of 0 is negative 3. So you've got 1 times 6 minus 6, which equals 0. So your point is that g of 0 equals 4. So that's 0, 4. Your slope is your g prime. So your slope is 0. It just ends up being y equals 4. If you want to write it like this, y equals 0 times x minus 0 plus 4, that is technically correct. But that equals y equals 4. So it's just a horizontal line.
I think I would write it out like that. I think I'd write it out.
I sometimes do, just because.
I get nervous about it.
Yeah.
I don't want to risk it.
And I feel that way too. Sometimes I do that as well. All right. So, in my opinion, A, B, and C are not too bad here.
D is bad.
But D is going to be a little worse, but it's not that bad. Okay. All right, so they ask us to find the second derivative. Actually, they don't ask us to find the second derivative. They give us the second derivative and ask us to show how you get that. So they're being really nice because they're giving you the answer, right? And so, but you need to show the steps to get that. Then they're asking about a local maximum or minimum. So what they're wanting you to do here is use the second derivative test. We did not do the second derivative test a lot. Okay? So second derivative test, so I'm going to just write this over the side. This is not part of the problem. But for our second derivative test, first of all, you have to find the critical points of, or well, let's see. First you have, or let me just say it this way. G prime of x has to equal 0. So the first derivative has to equal 0. That tells you you have a critical point. And then you're going to look at the second derivative. So if g prime of x is greater, g double prime of x is greater than 0, what does that tell you if the second derivative is greater than 0 if it's positive? Not increasing, it's the second derivative. Concave up. This is a double prime. So if my graph is concave up, and I have a critical point where my first derivative is 0, what have I got there? Minimum. But if my second derivative is less than 0, concave down, looks like this, and that is a maximum. Who is playing music? Please turn it off. Turn that off. Okay. Alright. So for this problem, we need to find or show how they got the second derivative first. Then we are going to show that if that second derivative is positive or negative. So I'm going to write down that g prime of x again because it's off my screen. It's e to the negative 2x times 3f of x plus 2f prime of x. What are we going to have to use to take this derivative? Product rule. We have this stuff times what's in the parentheses. So g double prime of x is going to be e to the negative 2x times, we're going to take the derivative here, 3, Daniel, quiet, 3f prime of x plus 2f double prime of x. Now, it's just half of it, because that's f times g prime. Now we've got to do plus g, so all of this, 3f of x plus 2f prime of x times the derivative of our first part. What is the derivative of e to the negative 2x? E to the negative 2x times negative 2. So, these two are multiplied, so you don't have to, but you could put those there. So you've got this e to the negative 2x with both of these terms, so you could just pull it out front. And so that's going to give you 3f prime of x plus 2f double prime of x. And then we pulled this out front here, right, with that one. But we still have this negative 2 that has to be distributed here. So we're going to get minus 6f of x minus 4f prime of x. And now we just need to combine our like terms. And that's going to drive me crazy. We've got negative 6f of x. And then we've got a 3f prime of x and a negative 4f prime of x. That's going to be minus f prime of x. And then plus 2f double prime of x. Which you want to make sure looks exactly like what they gave you as the answer. Okay, the answer's there, so make sure it matches. Even if you don't know how to get it to match, write it. You might not get credit, but you may.
Okay. I was going to say, can you like work? I guess you can't really work backwards too much on this one.
This would be hard to work backwards.
There's software you can, I've done it before, where you give an answer and you just like, you forget it, but you work backwards. Not really.
Sometimes it does, but not much on the AP question.
Second derivative or something, very good derivative or something. Like this is the like you know how does that on the FRQs?
Mm-hmm.
So then you work back.
All right. So we've got our second derivative. Even if you didn't know how to get the second derivative, they gave it to you. So now we want to know, is that second derivative positive, negative, or 0? Actually, let's see. We really do need to know that first derivative is 0 first. But we already know that because right here we found g prime of 0 and it ended up being 0. Right? So we already know that g prime of 0 equals 0. So we're going to find g double prime of 0 now. So e to the negative 2 times 0, negative 6 f of 0 minus f prime of 0 plus 2 f double prime of 0. So this is 1 times negative 6 times 2 minus negative 3 plus 2 times 0. And so we get negative 12 plus 3 here, so we get negative 9. And we would need to say, in this case, since f double prime of x, not x, don't do x, do 0, because we're talking about just at that point 0. 0 is less than 0, f is concave down, and since f prime of 0 equals 0, f must have a maximum, relative maximum, at x equals 0. Relative or local should be there. That's a question I don't really know as far as AP graders go, whether or not they'd let it slide. But often, like, just to make sure you've answered the question correctly, look back at what the question asked. In this case, it says, does G have a local maximum? So that might, like, jar your memory to think back, oh, I should put local maximum or relative maximum there. All right, questions? All right. I guess I'm going to give you the rest of the time to look at the other FRQs as long as you guys are actually looking at them. Because we do not have time to squeeze in the notes here. So I will adjust that assignment for the notes here. Also, next week, the plan was to review and then test on Tuesday and Wednesday, because we won't be here Monday for Martin Luther King. However, Dr. Cox has sent out an email to the teachers. This is not good, actually, in my favorite.